And now we just need to click Create Dataset. Great. So now we have our dataset filtered with only users that don't have an international plan, and we created a new variable, which is a transformation of previous one. In this case, we are discretizing the number of voicemail messages variable. Okay, so now let's create our model. But before, an additional step is that something that you usually use, we always do when we work in this kind of problems, of use cases. Something that we usually do is splitting training and test data. So we have a big data set where we want to have something like 80% of the rows for training the model, and we usually keep apart 20% of the rows that will be used later for evaluating the model to check how accurate my model is. So in this case, in BigML, doing this is as easy as going here and say train test split. So you select the percentage of variable that you want for training and the percentage of rows that you want for testing, and just click here, create train test split. So if you move to the dataset list, you will see that two new datasets have been created. One with something like 2.4K rows for training, and another one with 600 rows for testing. So now let's open the training one. And let's create the model. For it, we just need to go here. In this case, for instance, we are going to create an ensemble. In this case, the default ensemble that you will create with BigML, if you don't modify any of the configuration parameters, is a decision forest with 10 trees. So you just need to create ensemble. As you saw, you can use the default parameters. In this case, for the ensemble, is a decision forest with 10 trees, or you can modify any hyperparameters to check many different kind of model. We will talk a little bit about this later. So now I have my model ready. If you go here, you will see the list of trees. You may know that the kind of model that we train, a decision forest, is a model that combines the prediction of, in this case, 10 different decision trees. So you can check each one of them, or you have the PDP graph to check the output of the model depending on the different inputs. So for instance, to do a very quick test, let's do a prediction. Imagine that we have a new client with this data, for instance, with a total day chart of 30, with total day minutes of 275, without a voicemail plan. Well, all this data. If you fill all the data, you will see here the prediction of the model. In this case, for this data that we provided for this specific customer, the model is telling that the customer is not going to churn with a probability of 99%. You can even click here. Let's go here, and you will see a complete explanation of the prediction of the model. So in this view, the model is not only telling you that the client is not going to move to another company with a probability of 99%, but it is also giving you an explanation. It is giving you the importance of each variable for your specific prediction. So for instance, we can see that the most important variable, that the variable that is most important to decide in this case, in this specific case, whether the user is going to churn, is the total day chart with an importance of 66%. So we are not only giving you the final prediction, but also we are giving you something that it is extremely important when you want to use this kind of modeling in the real world, which is the explanation of the predictions. Okay, so let's move again to the slides. And all this was to show that we have an intuitive interface. So imagine what things you will have to do if you wanted to do all the things that we did with 4 or 5 clicks manually with another programming language, with a library, whatever you usually use. In this case, using BigML, with just a few clicks, we were able to upload a source, to transform it, to filter it, to create a new data set. Then we split train and test data, and then we finally were able to train a model and do some prediction with it. Everything, as you said, in 5 minutes with just a few clicks. Okay, so now let's move to the next point. A second. Okay, so according to ChatGPT, a no-code machine learning platform should offer some kind of pre-built templates. So ChatGPT talks about providing a variety of pre-built machine learning templates for common use cases such as image recognition, sentiment analysis, or even recommendation system. So related to this point, let me show you different things. For instance, if you go to this bottom part of the BigML web page, you will see this gallery tab. Here you have 3 different options. You have the dataset gallery. Let's open it. Here you have many examples of dataset ready to be used in BigML. So they are already, you just need to, they are already ready to be used at BigML, and you just need to click buy here. All of them are free, and you will see that dataset in your account. So this is the first thing related to having some kind of pre-built templates. Additionally, you also have models in the gallery. Sorry, you have let me go here. You have a gallery of models. This is the same as the previous one, but in this case, instead of having data sets, you have already trained models. For instance, this one here is a model for sales prediction. This is based on ETSY.com data, and it is predicting the number of sales based on some statistic about the shops, such as the items, follower, feedback, etc. And additionally, in the gallery, you also have scripts. This is extremely important because it provides some ready to use workflows. I didn't talk about them, and I could be 1 hour explaining to you how BigML workflows work, but they basically are able to encapsulate some common steps. For instance, this one here, the remove anomalies workflows, is something that we usually do when we are dealing with tabular data, and we train an anomaly detector that then we use to remove anomalous instances from our data set, because it sometimes helps you creating more accurate model. If you remove noise from your data set, if you remove extreme cases that are very unlikely to be seen in production, when you train a model, you will have a more accurate model. This is a very common technique in machine learning, and this implies creating creating an anomaly detector, then using this anomaly detector to detect the 10 or the 20 most anomalous rows, and then filtering our data set to remove these rows. These are usually 3 or 4 steps that using this script that you can very easily download from the gallery, you will be able to automate. With 1 click, you will do all the steps automatically. So the same that we have for remove analysis, we have for a lot of different machine learning techniques. For instance, this is recursive feature elimination. That is a script to select the best features from a data set. So for doing feature selection, you have other other scripts for feature selection, and many other WSML scripts or workflows. Okay, additionally, related to this point too, let's move again to the dashboard, and let me show you a new data set. This one here. So I uploaded a zip file to BigML that contains many different images from CCTV systems, okay, from cameras, security cameras. And these images are separated in two different folders inside the zip file. You have one folder called Fire that contains images from security cameras where there is some fire in the string, in the image. And you have other, let me find it, another folder that is called, I think is default, yeah, that are common situation without fire. Okay, as you see, BigML already analyzed the zip file and automatically add the label field based on the of the name of the folder. BigML understand that there are two kinds of images. One is the default image and the other one is the fire image. So imagine that we want to build a simple classifier. We have a system that collects images from CCTV system and detects if there is some fire in the images to raise an alert or to call the police or whatever. Okay, so when you upload a zip file with some images to BigML, you will see this panel. This panel lets you configure which kind of image analysis you want to do. For instance, for this case, we are using all the options. We have many different kinds of analysis, some of them related to the dimensions, some of them using the wavelet transform, histogram of gradients, and you can even use a pre-trained convolutional neural network as a feature extractor. This means that we already pre-trained convolutional neural networks with huge data set, with a huge number of instances with very different cases, and you can reuse this convolutional neural network that we trained for you to be used as a feature extractor in your problem. Okay, so from this source, as always, we can create a data set. This will take a little bit because it is analyzing every single image in your data set and applying all the feature extractors that we selected. So as you expect, a huge number of fields will be created because each one of those feature extractors will be creating a lot of new fields. But what is the interesting point of this? The interesting point here is that we are transforming a zip file with some folders into an actual data set that we can use in BigML to do everything that we were able to do previously when we were working with CSV files. So you can do something. Let's move again to the first page. You can, from this data set, you can do everything that you usually use with other kind of data sets. For instance, you can create supervised models. You can create unsupervised models. For instance, something very, very interesting that we found in many use cases to be very, very useful with images is using anomaly detectors. For instance, you could use an anomaly detector to detect some anomalous situations in cameras. In this case, for instance, let's do a simple supervised model. So as always, let's do a train test split. Let's put usually the BigML seed. This is not important. So we are splitting our data set in training and test data set. Sorry. So as you can see, this is exactly the same way to work as we were using before when we were dealing with CSV file, but now we are dealing with data sets that contain images. Okay, it is in progress and it is now ready. So now from it, in a very, very easy way, the same way we used before, let's create an ensemble with temp model. So now we are training an ensemble to detect if there is fire in an image. So it is a binary classification, fire or no fire. Okay, it is finishing. Great, so we have our model. And in the same way that we did before with our charm prediction classification model, we can do with this binary classification model. So imagine that now we have a new image. Let's move here, for instance, I have some example. A new image from a security camera, and we want to know if there is some fire in the image. Let's upload an example image. I uploaded this image, and let's predict. Okay. And this is the prediction from the model. For that image that we uploaded, the model is predicting that there is fire in the image with a probability of 81%. You can even see the single prediction made by each different tree in the decision forest. But the important point here is that we were able to build the image analysis features at BigML in a way that once you move from the source to the dataset and you selected the feature extractor, everything is the same. You can create the same supervised resources, the same unsupervised resources, so you can use everything that we built in the past for a spreadsheet or for tabular data sets. You can reuse it for this new kind of data, which are images. So I think that many of you, this is even for those who have worked before with BigML, this may be new because it is one of the last releases we did some months ago. Okay, let's move to the third point. That remember that we were seeing all the points that ChatGPT considers that are very important in order to build a no-code machine learning platform. So related to data, ChatGPT was talking about data integration. So it considers that a no-code machine learning platform should offer seamless integration with various data sources. So it should allow users to import their data set from spreadsheets, but also from databases or even cloud storage. We already saw two different kind of files. We started building a source from a CSV file, and then we built another source from a zip file with some folders and images. But for instance, we can do other interesting things, such as importing data directly from a database. So for doing this, let's go here and let's say I want to import a source from Postgres. That's for those who don't know, Postgres is one kind of database. So I already created a selector, a connector, sorry, with the data needed to connect to a public Postgres instance. I have a Postgres instance running in this specific domain at this port with a given username and a password. So I provided all the authentication data to BigML, and BigML was able to connect directly to this database. And when you connect to this database, you will obtain all the tables in your database. So we have 3 tables in our database. For instance, let's explore this cars table. And look, BigML was able to retrieve all the data in this table from an external Postgres database. And you can, if you are an expert, you can even run your own SQL queries. For instance, imagine that I want to modify this query and I want to select all rows from the cars table where the city is equal to, for instance, Sacramento. And you click here, and as you can see, BigML was able to apply this query directly to the database and retrieve the important data. So in this case, let's, for instance, let's remove the filter and let's import all the data from the cars table to a new source called cars. And additionally, for instance, let's import also from the same database all the information from the table users. So now let's go to the sources list, and you can see here that the cars source was already created. BigML was able to retrieve all the data from the external databases, and we have some information about some cars here. We have some information such as the price, the color, the VIN, the year, model, and many other things. We have some information, for instance, about the seller, the username of the seller, and this is very interesting field because we can use this to join this information with information from the users table. If you look here, this is a common users table where you have some information about users such as the full name, the first name, the last name, the username. So this is how you usually find data in real world. Usually in databases, you will have data normalized. But to do machine learning, you usually want a single source or in this case, a single data set with everything. So let's create the data set for both sources. And now we can do something very interesting, which is joining both data sets into a single one. So we know that there is one common field between both data sets. The seller here is the same as the username in the users table. So using BigML, we can very easily join both data sets. So we want to perform a left join with the users table, and we want to join the seller field with the username field in the users table. And with a single click, we have all the fields that we will appear here in a few seconds joined. So something that you will usually do with SQL or in Python with pandas, you can also do it here inside BigML. Even for most advanced users, you can also actually provide some SQL queries to BigML, and it will be able to understand them. So this is always our philosophy. For more expert users or programmers or technical users, have some tools available inside BigML to do things like providing some SQL queries, even complex ones. But simple users that don't know how to code, they can still use BigML, and they can, with just a few clicks, as I've just done, they can, for instance, in this case, join two data sets in a very specific way. So I want you to understand that this is our philosophy, making the platform simple enough for everyone to use it, but still flexible for expert users that want to do more advanced things. So another thing that ChatGPT was considering that it is very important in a no-code machine learning tools, is having some automated model selection. I will be very fast on this because you may know that we provide OptiML. OptiML is our AutoML tool. Automatically, for instance, let's open this OptiML that I created some days ago from the churn data set. And look here, automatically OptiML created a big amount of models, sorry. Actually, it tried different hyperparameters, different training configuration for each one. So in a smart way, based on the input data, BigML is able to train hundreds of models, and at the end of the process, it will tell you which are the models that provide the more accurate predictions for your specific data. For instance, in this case, the best performing model is this random decision forest that is using 91 models, 91 trees. And it gives you the phi coefficient and the area under the rock curve for all the models tested. So this is called Bayesian optimization. And this is the AutoML solution that BigML provides, so that you don't need to manually create ensemble, deep nets, simple trees, logistic regression, and all the kind of training supervised models that we offer. You just need to create an OptiML, and after the given amount of time, BigML will give you the most accurate models for your data. The two last things that ChatGPT considers that are important for this kind of no-code machine learning tools is explainability. And you already know, and I already showed to you, that you can see the explanation of every single prediction. But you also have a lot of tools inside BigML that try to make models more understandable, more explainable. So you can see things like you can explore decision trees, or you have a huge number of curves to show evaluation. You have the field importance of each field in your data set. So I encourage you to use BigML, do the simple example I did today at the beginning of the session, and check how in every single step you have a lot of information, a lot of graphs, to try to make you understand not only the prediction of the model, but why the model is doing that specific prediction. So just as a simple example, if you go here for an evaluation of the churn model, you can see a lot of metrics, but also many different curves, such as this precision and recall curve, the rock curve, and many other things, trying to make you understand how the model is performing. And last but not least, ChatGPT considers that the models that you create using this no-code machine learning tool should be very easy to deploy to production environment with minimal effort. So something very important to know about BigML is that as soon as you train a model, this model is ready for production. So if you go, for instance, let's go to the churn model that we created. If you go here and you say download actionable model, and you select, for instance, Python, the common programming language that many of you use, you will see here all the code that is actually, there are a lot of comments, but it's actually 5 or 6 lines of code that you need to do prediction with this model. So you have some authentication data to ensure that you are the person that created the model, and you have an ID for the model, and with just this line of codes, you will be able to integrate this model in your big product. So you can decide if you want to download a local version of the model, so that you don't need even internet connection to use this model, because it will be running in your own machine, and we provide some libraries to be able to do prediction with those kind of models. or you can use remote prediction, and you will take advantage of the smart infrastructure of BigML that will automatically expand new server when they are needed, when there is a peak in demand, and all these smart features to deal with the infrastructure. So just to finish, as I'm going out of time, but just to finish, I want to mention that this was, let me go here. This was just the tip of the iceberg. It is very difficult to summarize in 45 minutes all the things that BigML can help you, can do for you to help creating machine learning, complex machine learning models and workflows. And if I had more time, we could have talked a lot about our smart infrastructure, our distributed backend. You can host your own version of BigML so that data is always inside your firewall. You don't need to send your data to an external server. You can also see some interesting things about our Scriptify tool. All the tasks that you perform during a session, with a single click, you can automatically create a new script that will perform automatically all those steps in the future. So this is very useful, for instance, when you have new data and you want to recreate all the steps that you perform to train a model. So I encourage you to visit bigml.com, create an account, it's free, and start uploading your data. And the best way to learn how the platform works is uploading your data and testing everything and creating many different kinds of resources. So this is everything from my side. I don't want to extend more, but thank you very much. I will be happy to answer any question. This is my email, gonzalez@bigml.com. I'm happy to help you with everything that with every question that you may have about BigML. So thank you very much for listening to me today.
Pablo, can you hear me?
Yeah, I hear you.
Yes, so thank you so much for that very hands-on question. So I believe the participants, they have they've learned one or two things. So please, participants, if you have questions, kindly drop your question in the chat. My colleagues will be picking that up. So, and then I also like you to share what you have learned so far. So this is very explicit, no code AI. For those that do not like to code, so Pablo has done justice. So showing you how you can train your model, clean it, do a whole lot of things, and with little or no code. So please share what you learned. We also like to pick your question. So Pablo, can we just give them like a minute to quickly drop their question?
Okay, happy to answer any question.
Okay, so for those on site, please write your question in the paper and just pass it forward so that I can read it out to the speaker. Thank you, Joseph.
Okay, there is a question about the limitation of BigML. Shall I start answering it?
Yes, please
okay.
go ahead.
Okay, great. So related to the limitations of BigML, if you go to bigml.com pricing page, you will see the amount of data that you can upload with every different subscription plan. So as I told you, you can start today with a very simple, with a absolutely free account. But when, for instance, this first account, it will be limited in the number, in the maximum size of the data set that you can use. I don't remember now, but I think it's something like 16 megabytes. And the other limitation there is that you can do only 2 tasks in parallel. As you saw today in BigML, you can do many different things at the same time. You can train 2 models at the same time. Actually, the OptiML tool is going to be training as much models at the same time as possible. So related with the plan that you are using, we offer some premium plans. This number of parallel tags and the maximum size of the data set that you can use will be higher. These are the two limitations depending on your account. But even with the free account, you will be able to use absolutely all the resources in the platform, all the supervised model, all the supervised model, all the unsupervised model, the WSML scripts, everything. Just limited by the amount, the size, the maximum size of the data set that you use. So there is another question about natural language processing problems. And yes, I didn't have time to show it today, but we also provide in a very similar way to how we deal with images, that when you create the source, you select the image extractor that you want to use. When you upload text, you can also select the feature extractor that you want to transform text into some tabular data. So the idea is the same. When you move from the source to dataset, BigML will automatically transform your text fields into some other fields ready to be used for supervised and unsupervised learning models. You can test it very, very easily. Just take a data set that contains some text fields, and you will see that BigML will automatically analyze them.
And someone is asking, hello, Pablo, can you hear me?
Yeah.
Okay, so I have a question here on site. So the person is asking, is there a way to export those charts that were created on BigML? Can we export them out?
Sorry, I wasn't able to hear you well. Can you repeat it or even write it, please?
Can you hear me?
More or less. There is a little bit of echo, but okay, let's try.
Okay, can we export the charts created by BigML? How can we export the visualization? Can we export?
Okay. Thank you. Now I understand. Let me check. I know that you can export some of them. For instance, when you are here, this is the PDP. This is one example of the graphs that we are generating. You have here this button that let you export as image with or without legends. And I remember that in other charts that we are generating, for instance, in the evaluation, you can do the same. When you open an evaluation and you open a curve, you can export that curve as image, or you can even export the whole evaluation as a CSV file, so that you can manually analyze them in Excel or any other kind of tool that you are used to use. So yes, you can export images, and you can even export the result from the evaluation and everything.
Very, very, very extensive. So I would like us to celebrate Pablo in the chat section. Please, I would like to see your fire emoji. Thank you so much, Pablo, for this insightful session. We really, really appreciate it. I believe the participants are really delving. For those who do not like so much of coding, the technical aspect, this is a win-win for the participants. And Pablo, really, really appreciate you speaking with us today. Thank you so much. So you can leave the call now. Thank you so much. Yes, thank you.
Thank you very much for inviting me. And I said I'm happy to help. You have my email, and I will be very, very happy to help with any of the problems or of the suggestion that you have.